bus impedance matrix. So in the previous sessions or from the first module onwards, we started studying about admittance matrix. We know the importance of the admittance matrix. By using admittance matrix, how we can find out the fault, that also we studied in the module 3. So the fault analysis can be done with the help of admittance matrix. Any type of the load flow analysis or the power flow analysis, if you want to do, the admittance matrix is mandatory. So we know the advantages and the significance of admittance matrix. Today's session we are going to discuss about the inverse of admittance matrix, that is bus impedance matrix. To form this bus impedance matrix, otherwise we call it as Z bus. The universally they follow two different methods. Number one, they can form the Y bus, and if they are taking the inverse, they will get the Z bus. That is method one. And the second one, and it is advisable to, that is building algorithm. So that is the easy methodology to find out the bus impedance matrix. Because if there are more than 5 or 6 buses are there, just imagine there is a 6 cross 6 bus and you need to take the inverse, it is not a easy process. But any n number of buses are there, and by using building algorithm, if you are able to form, it will be much easier. Right? To understand about this building algorithm, already we are having 4 different modifications. The type 1 modification, it is telling about the impedance. It will be between a new bus and reference bus, and the impedance between a old bus and new bus, and an impedance between old bus and reference bus, and the impedance between two old buses. Now listen, this combination is not exist, that is combination of two new buses. You can add two new buses. We can start a old bus and the reference bus, or we can start the new bus as well as the other the old bus, etc. Like that we need to do it. Now listen, just I am naming this bus, and here I am naming it as 1, and this is bus number 2, this is bus number 3, and the whole thing I call it as a reference. So a reference is there, and 3 buses are there. You know that you already formed that Y bus. Therefore, you know that if the number of buses are n, then the size of the matrix is also n cross n. So if the number of buses are 3, then size of the matrix will be 3 cross 3. Right? Now I am going to substitute this given impedance values, and for that particular impedance we are going to uh, form the bus admittance, bus impedance. Let us see the impedance values. This one is J 0.25, and here it is given as J 0.05, and here it is given as J, that is 1 or 1.0, and here it is J 1.25. Right? So the four impedances are there, three buses are there. Please keep in mind that is how we can form this building algorithm. We are going to uh, take all the types of modifications, right? Which type of the modification will be suitable, that we are going to take. So always keep in mind while we are going to form this building algorithm, right? This Z bus using building algorithm. Right. First thing is we want to see any reference buses are there. If the reference buses are there, from that if you are starting, it will be much easier, because the type 1 modification, it is telling about adding some impedances between the reference buses and the new bus it is given. Therefore, that value itself we can take it as a matrix. Right. Therefore, I am going to form this Z bus using building algorithm through various steps. Right. I am writing these steps one by one so that you can understand. Step 1, what I am doing means I am going to take one impedance, that is adding, I am writing right, adding an impedance here between 1 and reference I am adding. Therefore, impedance I am writing it as J 1.0, J 1.0, that is the impedance I am going to add, that is between first, that is new bus, because till now we didn't consider any bus. This is the first bus I am going to consider. Therefore, I am writing new bus 1 and the reference bus. New bus 1 and reference bus. So just I am going to underline these two things because that is very important. That is new bus or old bus, that is much important. See, this is new bus and next one is a reference bus. Right. So if we are adding the new bus and a reference bus, we can take the value as it is as a bus matrix. Therefore, my Z bus is, I can write Z bus is equal to right. Therefore, this step 1 is over. Now we can add, that is step 2. Now what I am going to do means I am adding an impedance. Is listen, adding an impedance where I can add next to that, that is J 0.25 is there, that is between 1 and 2. Listen, now the bus 1 is old bus and bus 2 is new bus. Why bus 1 is old bus means already here you taken the bus 1. Listen, the bus 1 already you taken. So the previous step that bus was new bus, but that was considered. Therefore now in this second step that is the old bus, right? So once again I repeat, why we call it as old bus, since we already considered that bus in the previous step. Therefore adding an impedance, and we can see the value of impedance, that is J 0.25. So that is J 0.25, that is the impedance between so now that is old bus 1 and new bus 2. I can write new bus 2. So now, as usual, I am going to underline this one, old bus. Since it is an old bus, it is a new bus. Now, if a old bus and new bus, if we are adding, how the modification is? That is the second modification, right? How we can write means, listen carefully, that is z bus is equal to. So if we are adding a old bus and new bus, the size of the matrix will be increased. Listen carefully. If you are adding an old bus and new bus, the size of the matrix will be increased. Therefore, so this is the original old bus, that is Z1, and now that is old bus 1 and the new bus is added, and the value is 0.25 is the impedance. So now what we have to do means, listen, this we can put as it is, and here also the same, because we are adding with 1, therefore here also the J1 will be there, and here also the J1 will be there, and here this corner term we have to add J1 plus J 0.25. I hope you can understand. This is what told in the type 2 modification. Right, in the previous session, we discussed about the type 2 modification. So the type 2 modification, we are adding the old bus and new bus. The old bus value will be as it is, and the new bus, that means at the corner, right? We have to add the new bus, right? At the end. Therefore, we can simplify it. So here how it will be, J1 will be there, and here J1 will be there, and here also again J1, but here it is J 1.25, right? So this is what we got it. So just I will put the matrix in the right form. So this is the Z bus after adding 0.25, that is J 0.25, right? So two elements were added. Now what are the other elements there? We can check. Between bus 2 and the reference is there, 2 and 3 is there. Now what I am doing means, I am going to add the bus 2 and the reference. You can add in any manner, that is up to you. Alright, so if I am adding from the left to right, so if you want, you can add from right to left, no problem, but always keep in mind, first we are adding the reference bus, it will be good. It will be like easier thing what we did now. Alright, therefore step 3, what I am going to do means, step 3, now I am adding an impedance. So here also adding an impedance. We'll check what is the value of that impedance. Yes, here the value of the impedance is 1.25, and that is between 2 and reference. Impedance J 1.25, we'll put J 1.25 between second bus and the reference bus. See, now the second bus is old bus and the reference is already there. Listen, the type 3 modification, it is like, that is old bus between old bus 2 and and reference. So just we will underline, right, this old, because that is important. This is old bus and that is reference. Now listen carefully. While you are adding, definitely the size will increase. But as per the modification, if you are adding any references, the size should not increase. Any new bus if you are adding, then only the size should increase. Right? So the step 1, we added a new bus. Therefore, the size will be, instead of 0, the size become 1 cross 1, right? So here you can see that the size increased. That is 1 cross 1. And second thing also, here in the step 2 also, we have added a new bus. Therefore, here also the size increase. That is 2 cross 2. 2 cross 2, right? The size increased. And the third step, the size should not increase. If the size increased, we have to go for elimination. That was the step given in the type 3 modification. Listen, the type 3 modification is old bus and the reference bus, right? Therefore, I can write it as old bus and the reference bus, right? Now, we have to write as it is, whatever the previous bus, that is equal to, here J1 will be there, and here J1 will be there, and again J1 will be there, and here again J 1.25. So this is the existing thing, right? And now we have to add this 1.25. That is how we can add. Listen, we are adding this to bus 2, right? Therefore, what is the value here? It will be the bus 2 value will be coming to the next row. Here also the bus 2 value will be coming to the next row. Here also the similarly the column. Both the column as well as the row, the bus 2 values will be repeated. Alright, therefore, here you can see that this is the second element. Second element will be repeated again. That is J1. Here also the same element will come. Right? That means J according to the our modifications that I given earlier, right, like this. And here also the same thing will come, that is J1. Here also the same thing will come, J1.25. Right, now what about this term? This term is as usual what we did in the previous case, that is J. So here you can see middle, that is 1.25 is there, plus our value, that is J 1.25 is the new value, that also we have to add, that is J 1.25. Alright, I can close this matrix. Just we simplify it, right, because 1.25 and 0.25 we can put it as 2.5, right? That is in the next step, that is here J1 as it is, here also J1, here also J1, J1 here, J 1.25, and here J 1.25, and here J1, and here J 1.25, and here J 2.5. Because 1.25 and 1.25, if we are adding, it will give 2.5, right? So this step is not over. Why? Because listen, now we got a 3 cross 3 matrix, right? But as per our modification, there is no new buses added. Old bus is there, and another one added is reference bus. Therefore, we have to convert it into 2 cross 2 bus by eliminating the third one, right? So how we can eliminate, right? So then we can write the size of the bus should not increase, therefore what we have to do means apply elimination method. So what we are going to do means we are going to apply the elimination method. So the third row needs to be eliminated. Therefore the n should be 3, right? So here n should be 3, and I will write you the elimination formula, that is set ij, right? Ij new is equal to z ij old multiplied, that is minus z in, sorry, I am putting y, listen, yeah, it is z, right? Z in z enj divided by zn. So this is the formula for elimination. I hope I given it while given the modification of the type 3. Therefore, so all those things we are going to see, going to frame the new values, all right? So you can see that z11 12 21 22 value we need. Here also, please keep it in mind, Zij is equal to Zj. Right, that will be easy. And here n value we know, that is 3. Therefore, I am going to find Z11 first. That means I is equal to 1, J is equal to 1. That is equal to new value, that is equal to Z11 old value, right? That is there, minus Z13 multiplied by Z31 divided by Z33. Now listen, all the Z values are there, that is in the matrix, right? In the above matrix you can get all the values and you can find the new value, right? So just I am going to substitute the value. Z11 old is equal to, what is that 11? That is J1, right? That is, I am going to substitute the same value J1 minus, what is 13 value? 13 value is also J1, right? So 13 value is J1, 31 value is also J1. So J1 multiplied by J1, right? And it is divided by Z33 value is J.25. That is J, sorry, 2.5, not 0.25, 2.5. Right? And if you are substituting this one, right, you will get the values. So already calculated the value. Please check it with your calculators whether you are getting the same value of Z11 new, that is equal to, I got it as J 0.6. Please check whether you are getting the same value. Put it in the calculator. Similarly, now I need to find Z12. Z12 is equal to Z21. We know that Z12 new, that is equal to Z12 old minus Zin. I is equal to 1, n is equal to 3, then N3, that is Nj, n is equal to 3, j is equal to 2. Am I right? So divided by Nn, that is 3, 3. Right? Now what we have to do means we will substitute all those values from the previous Z bus, that is Z12 value in the Z bus is given, that is equal to J1 minus Z13 value is also, we know that J1, and that is multiplied by, that is 3 2 is J 1.25. You can check the previous bus, right? Divided by Z33 is J 2.5. Just you put all the calculators, all these values in your calculator, and you will get the value of Z12 is, that is equal to point J 0.5. Please check whether we are getting the same value with your calculators. And next, listen here, Z21 we don't want to find. Why? Because Z21 new should be equal to Z12 new. Right? Therefore, one more value we have to find, that is Z22 new. Z22 new is equal to Z22 old minus Z23 Z32 because I and J are 2. Therefore, it is easy for me to substitute Z33, right? And now we have to substitute the value of Z22 old. Z22 old is equal to J 2.25 minus Z23 value is equal to J 1.25 multiplied by Z32 value is J 1.25 divided by J 2.5, right? So this is the value we have to, that is equal to just to put everything in your calculator, you will get J 0.625. Now listen, now we got all the four values. If you are finding 31, 32, 33 values, definitely you will get 0. Right? If you want to try it with your calculators, you will get 0. That is the peculiar thing in the elimination method. Therefore, the new bus now, Z bus new, because all the values are new, therefore I can substitute, that is equal to J 0.6, that is Z11, and Z12 is equal to J 0.5, and that should be equal to 21, that is J 0.5, and 22 value is J 0.625. Now you can check this one, the new matrix. Listen, the new matrix is 2 cross 2 matrix. All right. So as per our formulation, the size of the new matrix should not increase, but it was increased. All right. And what we did, we eliminated the third one and we find out the original one, right? So just you see carefully, so this particular thing, this new matrix, sorry, okay, I hope you can understand. Yes, whether we added all the values, no, we added three values, three z values till now, that is between 1 and reference we added, between 1 and 2 we added, between 2 and reference we added. Now we need to add one more, that is J 0.05, that is the impedance we have to add, that we are going to add in the step number 4. Listen, this step 3 seems to be a little bit bigger, but it is very simple. Alright, if you are substituting in the elimination formula, you will get. Alright, now the fourth element we are going to add, that is in the step number 4. Sorry, yeah, that is in the step 4. So the step 4, what we are going to do means we are going to add an impedance, right? Adding impedance between impedance, which impedance, the value is J 0.505, right? J 0.05. This is the impedance value we are going to add between see bus 2 and 3. 2 already we consider, that is old bus, we can say old bus 2 and new bus, because third bus not yet considered till now, that is new bus 3, right? So now in this case, just we can underline that is old as well as new, it will be easy for us, as it is old and it is new. Now listen, if it is an old and new, wherever a new bus is coming, the size should be increased. Alright, the size should increase by 1. Right, that is in our case it is from 2 to 3, the size will be increased. So we can follow the same procedure as earlier. That is, this one is type already we know that type 1 modification, it is very equivalent to, that is z bus is equal to, we can write all the values as it is, that is j is 0.6, j is 0.5, j is 0.5, and here j is 0.625. So these values are as it is. Now we are going to add third bus with the second bus. Therefore the second bus values will be coming to the third bus, and in the diagonal we have to modify. That means the same value will come here, that is j is 0.5, and here also j 0.625, and here also the same value will come, j is 0.5, and here also there is j is 0.625. And now what about this one, the diagonal element, means we have to add the value, that is j 0.625 plus is the value we need to add, that is j 0.05. Right, if you're adding that value, yes, you will get the final z bus matrix, and here there is no need of any modification, or no need of any elimination like a previous step, right? So directly we can write the answer. Let us see the answer, that is z bus is equal to, just we can add these two and we can write, that is j is 0.6 and j is 0.5, that is j is 0.5, and here j is 0.5, j is 0.625, and j is 0.625, and here j is 0.5, here j is 0.625, right? And here we have to add this, that means j 0.625, it becomes j 0.62 plus 5, that is 7, 5, right? So this is the value we will get finally. So the final Z bus value is this one. Now listen, if you formed Y bus, and you will get a 3 cross 3 Y bus, and then if you are taking the inverse also, you will get the same value. Here we know that the size will be 3 cross 3. See the number of buses given in the problem, that is 3. Therefore the size of the impedance matrix is also 3. Therefore wherever if you are finding impedance or admittance matrix, you know the size never change, it will be as it is. Right, so I hope you understood. So anyway, once again I repeat, right, what we did for a glance. Listen, what this is the sum given, right? It is a 3 bus system, always keep in mind, and we are going to apply the modifications. First one we add, that is a new bus and the reference bus, so that is the j1 we had and the step 2 old bus and new bus, right? You can see the diagonal term, that is 0.25 is added, all other things are the same. And the bus 3 we added the old bus and reference bus, and here always keep in mind the size of the matrix should not increase. So the previous size is 2, then the next size should also 2, but it was increased to 3. Therefore what we did, we go for elimination. So after elimination we can see it come down to 2 cross 2, and now we are adding another one new bus, right? In the new bus we'll get the values as it is, right? The increased value, that is 3 cross 3 matrix. Right, so I hope you understood. So any queries?